inequality symbol because we multiply or divide by a negative number. So the interval notation is negative 321, x in this interval. Any questions on this problem?
I have a similar one, but the
Yes.
answer was wrong because of the union.
Yes.
But it was 2 and the absolute value of 2x minus 9 plus 10 greater than 16.
Good. What do we have to do first?
Take away.
Subtract 10. Very good. So 2x minus 9 greater equal to 6. What is our next step? Very good. The absolute value of 2x minus 9 greater equal to 3. If we don't know how to convert this, we will not be able to solve it. How do we convert this? Or into what?
Negative 3,
Say it again.
You just put the negative 3 on the left side, right?
So let's analyze these two. You see, this one says blah, 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 greater than or equal to 3. And this one says blah, 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 less than or equal to 4. They cannot be the same. It's not possible. Here, this says the absolute value less than or equal to a number. Here it says the absolute value is less than or equal to a number. So if I use the same method, it's not going to work. Remember, there are only two types of absolute value inequalities. This or this. If it's not this, it must be this. If it's this, it cannot be this. So which one is it? I don't want you to memorize this. I want you to read it. So here's how we read it. Find numbers whose distance from 0 is 3 or more. That's all you have to read. That's all you have to remember. Where will I find numbers whose distance from 0 is 3 or more? In between or outside. That's it. There are only two options. Outside. Outside means greater than or equal to 3, less than or equal to negative 3. That's the outside. The inside is this. So what is the idea here? Find numbers whose distance from 0 is 4. They have to be in between negative 4 and 4. This one says find numbers whose distance from 0 is 3 or more, to the right-hand side of 3 or to the left-hand side of negative 3. So this is 2x minus 9 and 2x minus 9. These are two completely separate inequalities. They have nothing in common. One of them has answers to the left-hand side of negative 3, and the other one to the right-hand side of 3. They cannot be together ever. So then, is that clear so far before we solve those? This is the key. Once I get from here, now this is a piece of cake. But I have to understand the difference between this inequality and this inequality. They mean totally different things. Do we see it? Better? Okay. So you're going to get very experienced with this, but with practice. Just one or two examples is not going to be enough. Okay, so 2x greater than or equal to 12, because I move 9, and divided by 2, x greater than or equal to 6. Same thing, I add 9, 2x less than or equal to 6, I divide by 3, x less than or equal to 3. This is the one that has to have the union in the solution. If it doesn't have the union in the solution, something is wrong. This one says to the right-hand side of 6, and this one says to the left-hand side of 3. Both are brackets because of the equal symbol. Does it make sense? Once you establish the difference and you understand the difference between the two, you will not make a mistake. You don't have to memorize anything. Good. Next question, please.
Why did you go from 12 to 6 to 3? Why
See.
did you go from,
Okay, can anyone explain how we got from 2?
yeah, but then you did divide it by 2 again.
Okay, maybe there is an error. So let's check. I make mistakes too. Let's try. I move 9 to the other side. 9 plus 3 is 12. 2x divided by x is 2. 12 divided by 2 is 6. This is one solution. Now, 2x, I move 9 to the other side. 9 minus 3 is 6. And I get 2x less than 6. And then I divide this side by 2. I divide this side by 2, and I get less x less or equal to 3. Better? Okay. It could be confusing, I know. Good. Next question.
Column 3, how to simplify.
Which one?
Column 3.
Yes. So now, first of all, let's look at our handout. We have a handout that I gave you, and I would like to look. It's called Simplifying. Everyone has one. I'm just looking for one for me. Simplifying by factoring. Let me know once you find it. Simplifying by factoring. And do not forget to look at all these problems. So everything from 1.1 through 2.4 till this point. All problems have the answers in the back. If you need another document like this with recommended problems, let me know. I have plenty. I gave it to you on the first day of classes. It's in the packet if you got it.
The simplified one.
No, that one too. This is the recommended problems from the book. Okay, so I would like to look at those examples. Please choose. They send me too many for some reason. 2 people work on my document, and they send too many. I don't want to shred them. Actually, I want to.
So you want this paper, the one that says simplification by factoring?
Correct.
And
So
the
That's it.
that is something not to forget.
Oh, okay.
So in preparation for the test, in addition to what we covered in class, I would like you to look at all these problems
Got it.
because this is the material for test 1. If you do not have this document, I know I gave it to everyone, but who knows, maybe I missed. Let me know and I give you another. Okay, so let's go back to the last page of this document. Do you have it? I have plenty if you don't have it. Okay, so I'm going to select a problem and you will select another in a minute. Before I select the problem, I would like us to just analyze the following situation. Let's say I have x to the 4th minus x squared plus x. Do these 3 terms have anything in common? X. To which power? To the 4th, to the 2nd, to the 3rd, to the 1st? Right. Why to the 1st? Because the 1st is the smallest of these 3. I have 4, 2, and 1, so only 1 is a common factor. At the back. It's at the back. If you turn that to the back, the very last page. In a minute, we'll pick a problem from there. So now, what do I have to write in parentheses, please? From power 4, I subtract power 1. What do I have left? Excellent. Minus. From power 2, I subtract power 1. What do I have left? X plus 1. I have to have 3 terms. I started with 3 terms. I have to have 3 terms in parentheses. Otherwise, I will not be able to check. This times this, copy the base, add the exponents. This times this, copy the base, add the exponents. This times this is x. Agreed, everyone? Okay, this is the same idea that we're going to use for all these problems. However, here it looks very simplistic. And here it's not going to look very simplistic, but that's it. This is what we're going to do, nothing else. Okay, ready? Okay, so would you like to choose the first problem, or I will choose the first problem? All the answers, not step-by-step solution, but the answers are here. No, I don't want to do the fractions just yet. I want to start with something simple, and then we'll get to fractions. And then you're going to have to do all the other ones at home. So first, let's do 4, and then we'll do one of the fractions. So number 4, so 4, 3x plus 1 to the third times 3, 2x minus 5 cubed plus 3x plus 1 to the fourth times 3 times 2x minus 5 squared times 2. Do not waste your time to look for this document. I have plenty. So if you didn't find it, just let me know. Okay. Good. So where is our starting point? First of all, I have to clean those two, or I have to clean the problem up. How do I clean it up? First, I see a 4 and a 3 as factors. I'm going to multiply them and put them in front as 12. And then 3x plus 1 to the third, and then 2x minus 5 to the third. The same drill here, 3 and 2, that's 6. I see a cell phone under the table. 3x plus 1 to the fourth, and 2x minus 5 squared. Please put it away. Okay, so now next question I have for you is how many terms you see here? Terms. 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 I guess we do not know what terms mean. Okay. Okay, so then we'll come back. So we have two different ideas here. One is factor or factors, and the other one terms. Okay. Factors, when we talk about factors, we talk about multiplication. Only multiplication. Like, let's say 3x minus 2. This is the first factor, and this is the second factor. So when we talk about factors, we only talk about one operation, which is multiplication. When we talk about terms, we talk about addition and subtraction, not about multiplication. Example, 2x minus 3. This is the first term, and this is the second term. You could say that these are two factors, but this is a sum or difference, if you want, in this case, difference of two terms. So then coming back, let's take a look again. And I'm asking you how many terms we see here, and the answer is? Excellent. Great job. So obviously this is the first term till I encounter the sum. And then I have the second term. Excellent. Now my next question. How many common factors do we see? Or maybe I should say, how do we see common factors? Are there common factors in both terms? So this is the first and this is the second term. Yes, I see 12 and 6, so the common factor is 6. I see Excellent. To which power?
2.
Very good. We just talked about that. The smallest of the two. And
2x minus 5.
excellent. 2x minus 5. Which power? Excellent. 2. The smallest of the two. Perfect. So now let's see what is left. From this first term, I take 6 out. I take this out. I take partially this. Please tell me what is left before I write the sum. So I see a 2, very good, and I see a 2x minus 5. From 12 I took out 6, so there is a 2. This is completely out. From 3 I subtract 2 to get 1. I finally reach the sum. What is left from the second term once I have these 3 factors out? Excellent. No parentheses are needed. I just wanted you to see it where it's coming from. But because this is a sum, I really don't need parentheses around 3x plus 1. But I just want you to see it where it's coming from. Now, how do I verify? Let's say I want to verify my work. 6 times 2 is 12. This is here. This times this is this. Plus 6 times 1 is 6. This times this is 3x to the 4th power. This times 1 is this. Yes, I have to combine like terms. So this will be in brackets 4x minus 10 plus 3x plus 1, which changes into 7x minus 9. And that will be the final simplified form by factoring. There's nothing else you can do here.
We need the 4x.
2 times 2x, 2 times negative 5, plus 3x plus 1, 4x plus 3x, 7x, negative 10 plus 1, negative 9. Okay, now I think we are ready for a fraction. You choose the problem you like. Say it again.
Number 7.
Or we can directly go to this. Because you have the answers for this, you can do them later, and we can solve this one together. It's up to you. You decide.
Homework.
Say it again.
Yeah, no,
Which one?
the one without the answer. Yes.
This one. Okay. Let's start with that. If you feel that we need a third example, we'll do a third example. That's fine. So this is 2. X minus 3 to the third times 3, 4x minus 1 squared minus x minus 3 to the fourth times 3, 4x minus 1 times 4, everything over 4x minus 1 to the fourth. Questions so far? What is the starting point? What did we just do with the other one?
Factor out.
No, this is not how we started. Let's go back. Say it again.
Find how many terms.
No. What did we do first in the other one? Yes. In other words, cleaned it up. I see some factors in the middle, and I don't want to see those, right? So I have 6. X minus 3 cubed, 4x minus 1 squared, minus 12, x minus 3 to the fourth, and 4x minus 1 over 4x minus 1 to the fourth. So I just worked a little bit on simplifying those terms because they were all over the place. Do we understand the first step? Everyone? Yes? Perfect. So now, again, I'm going to ask the same question. How many terms we see? 2. Yes, this is a term. It's a compact, a product, whatever, several factors in a product. And then minus and this. So that this makes it as one term, and this is the second term. Next question I'm going to ask you, which I did not have an example before. I would like to simplify 2 of these with 2 of these because they are the same. Yes, you agree, or no, you don't agree? So we are allowed to do that. Okay, here's my answer.
So you're saying that the denominator 4x minus 1
Yeah, I want to simplify.
cancels out two
Yeah,
of those.
take away 2 from here with take away 2 from here.
Okay.
So is it possible or not?
No? Oh. At least I'll know.
What did we say when we solve rational equations? We only simplify. We only simplify,
Terms,
never terms.
factors.
We only simplify factors. Is this a factor in the numerator? Is this a factor in the numerator? No. No. 4x minus 1 squared is not a factor in the numerator. It's a piece of a term. We're not allowed to simplify terms or pieces of terms. So let's write that down. I blame it on myself. I did not specify enough. So we only simplify factors. Never what? Never terms, please. That's okay. That's why we're here, to learn. So never never simplify or never attempt to simplify terms or pieces of terms. Okay, I messed that up, so I'm gonna, instead of wasting my whiteout, I'm gonna say never terms or parts of terms. You understand now that 4x minus 1 squared is a part of a term. Would you agree? This piece is a part of a term. It's a part of this term. Okay, very good. So then I'm going to ask you how many common factors we see in the numerator. So I will continue right here. Exactly what we did a minute ago. Same thing. So do we see common factor, yes or no?
Yes.
Okay, what are they? Which common factors? Excellent.
X minus 3
Excellent.
4x minus 1.
To the, which power? Excellent. Very good. Now I copy 4x minus 1 to the 4th. After I'm done, yes. Now when I ask you, can I simplify a 4x minus 1 from the top with 1 from the denominator, what will you say? Why? Why yes this time? Because 4x minus 1 at this time is a, exactly, a factor. Exactly. Now it is a factor. Look at this. Look at the factors. One factor, the second factor, the third factor, the fourth factor. They're all factors now. So then I can simplify 4x minus 1. Perfect. So then can anyone tell me what is left in brackets? We are here. So we cannot jump. Please do not jump to the second term. I need something that is left over from the first term. I should have not simplified it before we wrote. My apologies. I jumped. Okay. So this is already, is still there. So please tell me what I write here. So 6 is out, x minus 3 cubed is out, 4x minus 1 squared, only one of them is outside, what is left inside? Right, I should have not jumped into conclusions just yet. So now I reach the negative symbol. You understand that when you multiply this times this, you have to get that. Otherwise, something is wrong. Is that clear?
Yes.
Okay, so then from 12, I took out 6, so there was a 2 left. From x minus 1 to the 4th, I took an x minus 3 cubed, so an x minus 3 is left. 4x minus 1 is out, no more 4x minus 1. So this is then 2 and x minus 3. My apologies, I confused you by simplifying before we wrote in brackets. Yes, Kayla, go ahead.
Alright, so I think I know the answer, but how did, so at the, up there when you wrote never, you have 4x minus 1 squared, right? And then down there, you said 4x minus 1 to the first power.
Yes, because we can only factor the smallest power. That's why I started with this example.
Right, I know.
For you to understand that I cannot factor out power 4 or power 2 or power 3. 4, 2, and 1. I can only factor power 1. So then here, I have power 2 and power 1. I can only factor out power 1.
Oh, okay. I missed the whole part.
That's okay. No worries. Okay, so now we combine like terms in brackets. This factor is gone now because we only have 3 that left in the denominator, and we're done.
Question real quick.
One more second. Just hold on 1 second. 6x minus 3 to the 3rd. And I have 4x minus 2x, which is 2x. Negative 1 and plus 6, which is positive 5. Yes, I'm ready.
How we took out 4x minus 1.
Yes.
So you want to do that once you set up that setup right there, not like you don't want to do it before, right? You know what I mean? Like back at the top. Like, knowing me, I'd probably do it right there. The 4x.
Here, simplify.
I would probably do it right there.
Simplify. But that's why I discussed that, so you don't do it. Yeah.
Wouldn't that be a
So that's why we wrote, we only simplify. Yes, I'm going to go back. What was it? So this is 4x minus 1 minus 2x plus 6. 6 minus 1 is 5. 4x minus 2x is 2x.
Oh, she's writing that stuff that we wrote. Yeah,
This is part of 2 classes before, right? You don't need me for that. Okay, is this clear? Do you think we need another example? If you say yes, please choose another. I'll be more than happy to go over another. It's up to you. Okay, anything else?
Could you someone want a,
From here?
yeah.
Okay. You know where these problems are, right? This is what we started with a month and a half ago. In case you forgot, I can show you where they are. Please, bless you. Please remember, just solving one of each type of problem will not help, will not be enough to master the topic. So that's why we solved so many different problems in class. And I ask you to bring more from my math lab. Okay, so please remember, just one type of each problem is not enough. Okay. Good, so this is what type of equation?
Rational.
Good, it's a rational equation, so we will write this. In case you are using my method. If you have a different one, please use a different one. I'm fine. We factor out the denominator. We have to state that x cannot equal 4 and x cannot equal negative 2. This is mandatory. No matter which method you use, you have to state the restrictions, please. Mandatory. And what do we do next? You can, if you'd like to use that method, that's fine too, I'm fine. But what I'd like to do is just find the least common denominator. and then decide the next step together. So if you forget the 0 and the equal symbol, you're not going to solve. You're going to just simplify an expression. So we have x minus 4 and x plus 2. And obviously the adjustments are needed for each fraction, except for the last one, which is 1. So here I need an x plus 2, and here I need an x minus 4. Please remember, all these involve a lot of steps. Please go back and redo the problems we did in class, including these ones. So then we have x plus 2, minus 5x plus 20, and minus 6. 1 multiplied by x plus 2, negative 5 multiplied by x, and negative 5 multiplied by negative 4, and negative 6 multiplied by 1. You want me to show you where these problems are in your notes? We have them.
From the beginning, right?
Yes, the very beginning.
But
Yeah.
in the notes, I don't know unless.
Let me take a look.
So in the notes, this is why.
Exactly. That's
You have
the same problem.
I know, but you said to do x minus 2. So
No,
that's
no.
why, and I knew it was x plus 2, but
That's why you wrote x plus 2. So
I know,
Yeah,
you
you-
told us to write x plus 2 there.
No, it's not possible.
I know, that's why I was
So
saying.
x plus 2. So just change it into plus. Got it. Okay, so we combine like terms at the top. So we have negative 4x, and this is plus 16 divided by x minus 4 times x plus 2 equals 0 or 0 over 1. So you have two options here. You either say a fraction is 0 when the numerator is 0. You have this problem in your notes. I copied it from there. And then x equals 4. Which date was that, Kayla? Do you remember?
The 27th.
The 27th of January.
It was like the second day, the first day.
Yeah, yeah. I copy problems from what we did in class, as well as my math lab.
For the test.
I'm sorry?
For the test.
A long time ago, a student, 20 years ago, said, your tests are more difficult. And I said, okay. So ever since, I picked problems from that were done in class. No one can say it's more difficult than what I do in class. At least that problem is solved. So what do we conclude?
No,
Exactly. No solutions. No solutions. Excellent. Next question, please. Let's get in as much as possible.
Number 9, what did you mean by using transformations?
I have no idea. I have to. Oh, thank you. I did. That is not included. If you remember, I may have said, but maybe not. That is not. This test included section 2.5. Yours does not. My apologies.
So don't worry about number
No, of course not. If I don't show it in class, you're not responsible.
like, if I couldn't find that problem, I would.
Exactly. You're not responsible. If I didn't show it in class, you're not responsible. And let me see, there may be something else, maybe not.
number 5.
Number 5, we want to do number 5. Where is 5? Yes. So the length of a rectangular tennis court is 6 feet longer than the width. Width, 6 feet longer than the width. If the court's area is 27 square feet, what are the court's dimensions? Yes, anything, any suggestions here?
Would be base times height.
Very good. So then 27 equals x times x plus 6, which means x squared plus 6x minus 27 equals 0, because this is a quadratic equation. There's nothing to it. We have to set it equal to 0. And now you have 4 methods. Which of these 4 methods you will not apply? Complete the square, absolutely. That's always the first answer. What is the second one that you will not apply? Taking square roots because it's not ready. So you're down to 2. Either factor, if it takes more than 30 seconds, forget it, and go ahead with the quadratic formula. Okay, so does it take more than 30 seconds to factor?
No.
No.
29.
Not possible to have a negative distance. So if x is 3 feet, how much is the length? 9. 3 by 9 is indeed 27 square feet. So x equals 3 feet, and x plus 6 equals 9 feet. Questions? Next in line, please. Please, anything, please, anything.
Can you move it? Just kidding. I think you just did that. Never mind.
That's okay.
8.
Which one?
8.
8. Let's do number 8. Very good. Number 8 is a piecewise defined function. Very good. Which is f of x, 2x minus 4 for x less than 1, and x squared plus 2 for x greater or equal to 1. You will not have a quadratic. Well, although it's part of a previous course, it's okay. I did not review this with you because it's part of 2.5. You will have a piecewise defined function, but not with a quadratic function in it till I show it to you. Okay? So you'll have 2 linear functions in there. But since we picked that problem, I have to show it to you till the end right now. Okay, ready? So a piecewise defined function, when we're asked to graph it, first of all, or any function, first of all, I look at the domain. And I hope you agree with this notation representing this inequality. Would you agree? Negative infinity to 1. Would you agree with the second one being 1 comma infinity? Would you accept that? Yes? Perfect. So then now I would like you to give me the domain of this function. Look at this and give me the domain. Excellent. Thank you. Negative infinity to infinity. Perfect. Which key x value needs to be in there? Absolutely 1. Of course, 0 will be in the table, but 1 will definitely have to be there. And right under 1, I will copy these 2 symbols, touching each other. The next step, I recommend write the functions right over those intervals. So between negative infinity and 1, which function do I use? I can only use one function, and one function only. Which one? Top or bottom? Excellent, indeed, thank you. 2x minus 4. Of course, for the other one will be x squared plus 2. Okay, so I already have, this is a linear function. I have x in there. I have 0 and 1, so let's plug it in. Plug in 0 and give me the answer.
-4.
Perfect. Please plug in 1 and give me the answer. And write it inside the parenthesis. Very good, -2. Please plug in 1 in the other function. Very good, write it inside the bracket. And let's pick also 2 on the other side. Okay, so then 2 times 2 is 4. 4 times plus 2 is 6. And this is our graph. Do not overlap the 2 pieces. Extremely important. From left to right, please give me the first ordered pair.
-4.
First ordered pair from left to right is,
0 over -4.
very good. The next ordered pair is this one, 1 comma, 1 comma -2, but this is an open point because of the parenthesis. And this is the left branch, or the first piece. It's a piecewise defined function. This is the first piece. Can anyone give us the next ordered pair in line? Well, obviously must be this. So 1 comma 3. What type of point is this? Full point, very good. And then 2 comma 6. And I'll show you, I know you remember, but we haven't discussed that. So this is the function. Notice that there is a cutoff or a threshold right here. One function is on the left, a totally different function on the right. If you graph something like this, I cannot even look at it, let alone give credit for it. First of all, this is not a function. By the vertical line test, it will not be a function. But this one, by the vertical line test, is a function. So please be careful. Please make yourselves a note anywhere you want in your notebook. Make sure that not to overlap the functions. Yes, please, go ahead.
The secondary arrow, whatever, is that supposed to be curved or is it
It's a yes, because it's quadratic. We haven't talked about it. I will not assume that you remember it from other classes. When we get to it, I will explain it. That's why your test will not have something like this, because I did not show quadratic functions in this class yet.
Can you do a problem that would be on the test?
Yes, a linear function. Something like this. Instead of a quadratic. Good. Anything else from here, please?
Number 4.
Number 4 it is.
Like, what is it?
Number 4. Is this a function?
Yes.
A yes answer is not 100% full credit.
Because it's also 1.
Excellent. That's 100%. Perfect. Find the domain. What is the domain of this function?
So 1 4.
Yeah, I think it's 0, 4. But like this. What about the range of this function? Yes, -9, I think it is 7, yes. X and y intercepts, if they exist. So the x-intercept is 3, 0. The y-intercept is 0, -9. Awesome. Please stop me if you have any questions at any point in time. F of 2. I will accept it because it's not easy to read, but I think it's -5.
Yeah.
Find x such that f of x is 5. Well, if we considered that it goes to 4, then this has to be a little bit lower than 4. But I agree it's difficult to read, so I will say f of x equals 5 really means x equals, let's say, 4.8. I mean 3.8. Because at 5, we considered at 5 to be 4, so obviously at 4, when y equals 5, it's a little bit before 4. So I said approximately 3.8. Yes?
I just want to make sure.
Yes.
For A, what is the function explained? What's a good test answer for explaining
By the vertical line test. That's the only way.
the vertical line test?
Say yes.
Yes, it's a function by the vertical line test. Yes. Very good. Next question, please. Anything?
Number 6.
Number 6.
7.